Hello everyone, and welcome to the first lecture video of STAT 251. In this video, we're going to talk about what statistics is and introduce some of the key definitions that we will use throughout this course. First of all, there are actually two definitions of statistics depending on the context. Statistics as a field, or the discipline, is the study of collecting and interpreting data. And data are collections of information taken together with a given context. One of the primary goals of statistics is to make an inference about a population based on information contained in a sample from that population. When we collect data from one individual, such as their age, we would expect that this data will vary among different individuals. Statistics is used particularly in areas where variation occurs, such as biological and medical sciences, or in psychology or engineering, and many other areas. The two types of statistics that we will be discussing are called descriptive statistics, which are methods that summarize and display information, and the other is called inferential statistics, which are methods used to make conclusions from a sample to the larger population. Now, generally, a researcher will apply descriptive statistics to the data first, and then inferential statistics to the same set of data. Now, let's introduce four important definitions, and some of which we have already been using. In statistical jargon, a population will refer to the collection of all individuals or items that we want to study. A sample is a subset of the population that is selected for study. Now, related to the population is a parameter, which is a numerical measurement which describes some characteristic of a population. And now we come to our second definition of statistics. A statistic, which is in singular form, is a numerical measurement which describes some characteristic of a sample. And to help remember how these terms are related, note that there are alliterations. So a parameter is a numerical measurement of the population, and a statistic is a numerical measurement of a sample. So let's look at an example of identifying these definitions in a study. Suppose that I want to know the average height of all students in this particular STAT 251 class. Now, because of time constraints, I will only select 30 students to measure their heights and then calculate the average height of these 30 students. So what are the population, the sample, the parameter, and the statistic of this study? So let's first identify the population. So the population is going to be all students in this particular STAT 251 class. The sample is the selected 30 students. Now, the parameter is the average height of all students in this particular class, and the statistic is the average height of these 30 students. So now let's suppose I were to line up every student in the class from tallest to shortest. How would the sample estimate of the average height of the 30 selected students compare to the true population average height of all students if I were to only select the tallest 30 students in the class? And how about only selecting the shortest 30 students? Well, unless all of the students' heights are the same, selecting the tallest 30 students would generally overestimate the true average height, and selecting the shortest 30 students would generally underestimate the true average height. Methods that are used to select a sample which over or underemphasize some characteristics of the population are said to be biased. Typically, there is no way to fix bias after the sample is drawn, and there is no way to salvage useful information from it either. And we want to avoid biased results whenever possible. If we want to make an accurate estimate of a population parameter, then we want to ensure that the sample that we obtain is representative of the population. And a method that we can use to select a representative sample is called simple random sampling. In a simple random sample, every sample will have an equal chance of being selected. And it can be performed with replacement, which means that an individual can be selected more than once, or without replacement, meaning that the individual cannot be selected more than once. And there are other methods that are used to select a representative sample and which are explained in the assigned readings. Whenever we collect data, it is important to be able to provide its context by identifying the 5 W's. So who are we collecting the data from? What characteristics are we measuring? Why are we collecting this information? And where and when we collected the data can have different meanings. And sometimes we will add how to this list as well. How the data was collected is important for determining whether we can make the correct conclusions. Who we collect the data from could be respondents, which are individuals that enter a survey. They could be subjects or participants, which are people on whom we experiment on. Or they could be experimental units, which are plants, animals, or inanimate objects. So what we are measuring are defined to be variables. And a variable is a characteristic that is recorded from each individual in the study. Qualitative or categorical variables are variables that name categories with either words or numerals. And qualitative variables can be further classified into nominal variables, which are variables that have no ordering, or ordinal variables, which are variables that have ordering among the different levels. For example, eye color, gender, or provinces are nominal variables. An evaluation asking, overall, this instructor was excellent, with the levels strongly disagree, disagree, neutral, agree, and strongly agree is an ordinal variable. Quantitative or numerical variables are numerical values with units that describes some quantity. Quantitative variables can either be discrete, which can only take on certain allowable values, or continuous, which can take on any range of values. For example, the number of classes you are taking this semester is a discrete quantitative variable, since you can take 4 or 5 classes, but you can't take 4.5 classes. And measuring distances is a continuous quantitative variable, since distances could be 4 or 5 centimeters, or any range in between them, like 4.5 centimeters. Identifier variables is a variable that uniquely identify each of the cases in a study. So some examples of identifier variables are student ID numbers or product identification numbers. We can use a data table to help us organize our data. The column titles in the first row tell us what characteristics are recorded, and the row titles in the first column tell us who we recorded the characteristics from. So in this example, we have the age, the student ID, height, gender, and grade as the characteristics, and we recorded them from the students, John, Carly, and Rob. So that concludes our first video, and we will look at displaying and describing categorical data in the next video. I'll see you then.